Hey everybody, today we're going to talk about volumes of cones. Now last time we talked about volumes of cylinders, and cones are a little bit similar to cylinders in that their base is a circle, but they only have one base instead of two, like a cylinder does. And we knew that the volume of a cylinder was the area of the base times the height. Well, the volume of a cone is 1/3 the area of the base times the height. Now remember that the base is a circle, so this is a general formula. This will work for any any cone or pyramid. But we can make it a specific formula since the base is a circle, the area formula is pi r squared, so we can change this to 1/3 pi r squared times the height. And that's a specific formula that will work for a cone. Okay, so that we've got that right there. All right, so let's find the volume of this cone right here. So, first thing we're going to do is we're going to write down our formula, 1/3 pi r squared times the height. And then we're going to fill in what we know. So, we don't know the volume, so that's just going to be V. That's what we're looking for. We know 1/3. We know pi. Now the radius here is 2, so this is going to be 2 squared, and the height is 6. Okay, so this becomes 2 squared is 4. 4 times 6 is 24, and 1/3 of that is 8. So the volume is going to be 8 pi, which is my exact answer, 8 pi meters squared. And in order to find out something that's more useful for most people, we're going to get out our handy-dandy TI-84 plus C Silver Edition graphing calculator, or some reasonable facsimile thereof, and go 8 times pi. And that gives us 25.13 approximately. And that's in, that's cubic meters, not square meters. Let's fix that. Okay, there we go. So, as I told you before, I always like to have the exact answer and the approximate answer on everything. So it's pretty easy to do. If you can do a cylinder, you can certainly do a cone. You just got to remember to slap a 1/3 on the front of it. Okay, so we're going to now in this one we're going to find the height of the cone. We're going to use the same formula though. Volume equals 1/3 pi r squared times the height. Okay, so over here we have the volume is 956, and we've got 1/3 here. We're going to go ahead and use 3.14 for pi. Now my radius, okay, I got to be careful here because they gave me the diameter, not the radius, so I got to divide that in 2, so that's going to be 9, and then I got to square it, and then I'm going to find h. Okay, so 9 squared is 81, and 1/3 of 81 is 27. So this is going to be 27 times 3.14. Okay, so 956 is going to equal 109.9 approximately H. Now, in my calculator, I've got more than 109.9. It goes out to 109.9127412. I'm going to leave that in there. I'm not going to clear that, and I'm going to use my answer key. So I'm going to divide both sides by 109.9 here. And that will give me H. So what I'm going to do is I'm going to go 956 divided by, then there's an answer key. It's usually at the bottom down here on your calculator. It says A and S. You usually have to push the second key to get it. Okay, and this calculator is right below the 3. And I hit enter, and I get 8.69 or 8.7, we'll say. And this should be approximately equal to. Okay, and that's going to be in feet. Approximately 8.7 feet. Okay. So there we go. Let's double check that. Divided by 3 times 3.14. Oh, you know what? I made a mistake. Let's go back and fix this. Okay, so this happens sometimes. I don't know where I got 109.9 here. Let's try this again. So 9 squared is 81, and then 1/3 of 81 is 27 times 3.14. 84.7. Okay. I must add something else in my calculator. This is 84.78. Okay. So I'm going to divide by, I'm going to go ahead and divide by 84.78. All right, let's try that. 956 divided by 84.78. 11.27. Okay. That's a little bit better. Yeah, okay, there we go. There's our height. So be very careful when you do this stuff. Don't want to make mistakes. All right, so here's a couple for you to do. On this one, you're going to go ahead and find the volume, and on this one, you're going to go ahead and find the height. So I'll give you a second to pause the video here and do these two problems, and then jump back on and see how you did. Okay, so on this one right here, volume is 1/3 pi r squared times h. So we're going to go ahead, we're searching for the volume, so there's our variable. 1/3 pi, the radius is 6, which we're going to square, and then the height is 15. So 6 squared is 36. 36 times 15 is 540 divided by 3. So this is going to be, the volume is going to be 180 pi, which is the exact answer. And then we're going to go ahead and multiply that by pi. And that gives me approximately 565.49. And that would be in cubic centimeters. Okie doke. On this one over here, go ahead and write down the formula again. 1/3 pi r squared h. Okay, now we know the volume is 7,200. We're going to go ahead and use 3.14 for pi. The radius is 15, so that's 15 squared h. Okay, so let's get to it. 15 squared is 225. Divided by 3 is 75 times 3.14. So 7,200 equals 235.5 h. Then I'm going to go ahead and divide by 235.5 on both sides. And I get approximately 30.6. And that's in yards. There we go. So hopefully that's what you got. And again, this should be an approximately, because I divided by, I used 3.14 for pi instead of the pi key. So there you go. Okay, you must answer a trivia question before the sand in the timer falls to the bottom. So you can see you've got an hourglass over here, you've got sand right here. The sand falls at a rate of 50 cubic millimeters per second. How much time do you have to answer the question? So we have a cone right here that we have to find the volume of that cone. Okay, so volume is 1/3 pi r squared times the height. So r is 10, so this is 10 squared, and the height is 24. All right, 1/3 of 24 is 8. 8 times 100, the volume is going to be 800 pi cubic millimeters. Okay, so that's approximately 800 pi is about 2,513.3 cubic millimeters. Okay, so we know that it goes 50 cubic millimeters per second, so we can go ahead and take this and divide it by 50. And that gives me 50.26. We're just going to round that to 50 seconds approximately. It's a little bit longer than that, but is a quarter of a second much time? Not really. Okay, so there you go. Now, let's talk about an oblique cone. We did this last time we talked about oblique cylinders. An oblique cone is a cone that leans to one side, so it kind of looks like this. Okay? The top of the cone, the vertex of the cone, is not directly above the center of the circle. So, you find the volume with the same formula. The volume is 1/3 pi r squared times the height. The only thing you got to make sure of is that you go straight down from the vertex perpendicular to the plane of the base. Okay, so this is the height. Now this over here is called the slant height. We're not interested in that. Okay, so the volume is going to be 1/3 pi. The radius is 7. We're going to square that times 10. So 49 times 10, that's 490 divided by 3. That's 163.3. Repeating times pi, so we're just going to go times pi. So the volume is going to be approximately 513.13 cubic centimeters. So not real difficult. Okay, you're going to get to do problems 1 through 25, the odd ones, and I will see you guys in class.